What's up, everyone? Welcome back. Patrick here, moving on to the next question. So we are given a triangle and we're told it has vertices A, B, and C, and we're going to let D be the midpoint of the side BC. And given that scenario there, given that triangle, we have to answer these two questions. They're two different scenarios here. So if triangle ABC has an area of 20, what is the area of ABD, of triangle ABD? And then if triangle ACD has an area of 11, what is the area of ABD and triangle ABC? So before getting into this, what I'm going to do is draw a diagram of what is happening. And I'm going to label this A, label this B, label this C. It doesn't matter which one you label as long as you're getting the points correct here, drawing the points correctly. Like for example, this point D is the midpoint of BC. It's going to be the midpoint of this side over here. So it doesn't matter how you rotate this triangle. And so notice that we're going to be creating, so this is point D, we're going to be creating other triangles here. So for example, notice here we're dealing with triangle A, B, and D. And so what we're going to do is we're going to create a line like this, okay, from the vertex A to that point D. And what's this line called over here? Whenever we create a line, if you remember, from a vertex to the midpoint of the opposite side of that vertex, that line, it's called a median. And one property of a median that we haven't gone over yet in previous videos, we've gone through how to find the equation of a median, but a property of a median is that it actually takes the area of that larger triangle that you're working with and it cuts the area in half. So the area of this resulting smaller triangle and this triangle, right, these two areas, they're going to be the same, right? And it's for any triangle. So you can draw any kind. Let's say we draw like an obtuse triangle, maybe something like that, right? Let's say we draw a median from this vertex to the midpoint of the opposite side, like that. Even though this triangle and this triangle, they look different, this and this are going to have the same area. You can have triangles that have different angles, different lengths of the sides, and they can still have the same areas. So that's what a median does. It actually cuts the area in half. Now, one thing I want to mention, you got to be careful when you're reading these theorems. You got to read them carefully. It doesn't necessarily mean that it cuts or bisects this angle over here, right? So this angle and this angle don't necessarily have to be the same. There is a case where they are the same if the triangle is an isosceles triangle, and we're actually going to go over that in a future video. That's going to be a different theorem. But for other triangles, these angles don't have to be the same, but the areas are always going to be the same no matter what triangle you're using. All right, so if you get a question saying a median bisects this angle for any triangle, that statement is false. But if you get a question saying the median bisects the area, cuts the area in half for any triangle, that statement is true. So you got to be really careful with the wording. So now that we know that theorem, we can go into these questions. So if triangle A, B, and C has an area of 20, so the larger triangle has an area of 20, what is the area of triangle A, B, and D? What's the area of this smaller triangle going to be? Well, it's going to be half of 20, right? It's going to be 10. So that's the answer to number 1. Part B, if triangle ACD, so this triangle over here, this smaller triangle, if that has an area of 11, what is the area of ABD, this triangle over here, and ABC? Well, we know these two triangles have the same area, right? The two smaller triangles. So ABD is going to have the same area of 11, and then ABC is going to have an area of both of those added together, multiplied by 2, which is going to be 22. All right, so pretty simple theorem. A median, remember, it always cuts a triangle's area in